In the last class, we had introduced the concept of coordinate systems and the three types of coordinate systems: a rectangular, a Cartesian coordinate system, oblique Cartesian coordinate system, and polar coordinate system. And now we are focusing on the rectangular coordinate system. We discussed the distance formula and the applications of distance formula, and we had discussed a few problems from the distance formula. Now let us do the section formula. So distance formula was the first one. Next is the section formula. So if P is a point which divides the line joining two points A x1 comma y1 and B x2 comma y2 in the ratio m is to n internally, then P h comma k, the coordinates of P, if they are h comma k, this will be equal to m x2 plus n x1 upon m plus n, m y2 plus n y1 upon m plus n. Okay, so let's say this is the line. A x1 comma y1, B x2 comma y2, and P h comma k. So internal division means that the ratio this P is an internal point that is lying on AB, the join of AB. We'll talk about external division later, but so this is M is to N. So if whole length is M plus N, this portion is M and this portion is N. So this is the ratio. So M times the other side coordinate x2 plus n times the other side coordinate x1 upon m plus n. Then m times y2 plus n times y1 upon m plus n. So this is the section formula. So we can prove this. It is not a difficult thing to prove, which I think in your class 10th you would have gone through this proof. I will do it very briefly. Actually, the proof is not so important, but I'll just give a hint which you can work it out. I'll not do the proof fully. This is P H comma K. It is based on similar triangles, basically. So this is A x1 comma y1, and this is B x2 comma y2. Now we draw a line perpendicular to we draw a line perpendicular to the y-axis and parallel to the x-axis so that it cuts these two lines. So this is A. Let's say this is P dash and this is B dash. And okay, this is A dash. I will say this is double dash. And let's say this is P dash, B dash. Okay. Now AP, so by similar triangles, now triangles A, P, P dash, A, P, P double dash, one, this point, and this point, this triangle is similar to this triangle. A, B, B dash are similar triangles. Okay, similar triangles. Then what happens if they are similar triangles? You get the ratio of the sides are same. So we get A P double dash by A B double dash, or P double dash B double dash is same as AP upon BP. So in similar triangles, this is the common angle. So this upon this, or this upon this, is same as this upon this. So we get this is M is to N. This is M is to N, right? So the ratio is the same. So AP double dash and P double dash B double dash, they have the same ratio by similar triangles. And since this is same as AP double dash by P double dash B double dash is same as A dash P dash by P dash B dash. So this also is divided in the ratio M is to N. So now A dash is equal to x1 comma 0. See this? This x coordinate of A dash will be same as the x coordinate of A. Why? Because they are perpendicular. This line perpendicular to the x-axis, parallel to the y-axis. So the coordinates of A dash and A, the x coordinate will be the same. So we get this as x1 comma 0. This one is x2 comma 0 B dash, and this is h comma 0. So A dash is this, then P dash is h comma 0, and B dash is x2 comma 0. Now we want to get h. So what do we get? Now we get AP dash by BP dash is M upon N. So sorry, a dash b dash by p dash b dash is m upon n. So what is a dash b dash? This distance AP, this distance on the x coordinate, on the x axis is h minus x1. H is the larger coordinate. So you get h minus x1 by p dash b dash. This distance is x2 minus h. Correct? From here to here distance b dash x coordinate is x2, means from the origin to b dash the length is x2. The x coordinate of p dash is h, means from origin to p dash the length is h. So if I want this length, it has to be x2 minus h. I hope it's clear.
Yes, sir.
So we get m times x2 minus h is equal to n times h minus x1. So from here we get mx2 minus mh is equal to nh minus nx1. So taking the negatives to the other side, mx2, I bring this nx1 this side, so it becomes plus nx1, and I take this minus mh to the right hand side, it becomes plus mh plus nh. So from here we get, if you take m plus n common, or sorry, h common, so you get m plus n. So from here we get h as mx2 plus nx1 by m plus n. Got it? What did I do? I didn't do any big thing. I just took symmetry. But exactly the same way we need to do for y coordinate. So the y coordinates, all right, I will write a different names, m q n. So a m b n, a m b n and pq. So similarly, exactly the same way, say m will be 0 comma y1, q will be 0 comma k, n will be 0 comma y2. So in similar lines, you can try this. You should try. Your concepts will strengthen if you try this. In similar lines, k can be found out to be m y2 plus n y1 by m plus n. Therefore, p h comma k is this mx2 plus nx1 by m plus n, m y2 plus n y1 by m plus n. So this is the section formula for internal division. All right. Now there is section formula for external division, which we'll not prove, but it is very same, pretty much similar. Now if p h comma k if p h comma k divides the join of a x1 comma y1 and b x2 comma y2 in the ratio m is to n externally, that is minus m is to n or m is to minus n. So external division, we write either we write it as m is to n externally, we emphasize this, or we write minus m is to n. Okay, then p h comma k is mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n. Instead of this plus sign here in the numerator and the denominator, we get a negative sign. So this is the section formula for external division. Very useful many times. Okay. It's a very important habit for students that as the subject is going on, you should maintain one separate notebook, completely a separate notebook for just writing down formulae. And as the lesson proceeds, you should write the key formulae of the chapter at one place. What does this do? Later on, as we proceed to other chapters, we tend to forget the formulae of the previous chapter. So we have to remember the concept and remember the formulae. So for that, when we go through the formulae list again and again, every month you should go through your formula list thoroughly, completely. Then you will remember, and you apply in solving problems, then you will remember. So these are important points of internal division and points of external division. Now note, the midpoint m h comma k of the line joining a x1 comma y1 and b x2 comma y2. The midpoint of the line joining a x1 comma y1 and b x2 comma y2 is h comma k x1 plus x2 by 2 comma y1 plus y2 by 2. How is this? Because midpoint is a point this is a x1 comma y1 and b x2 comma y2. Now midpoint is that which divides AB in the ratio 1:1. That which divides AB in the ratio 1:1. Okay, so this is the midpoint. So how do you get in this equation? Okay, in sorry, in this relation here, substitute m equal to 1 and n equal to 1. So we get x2 plus x1 by 1 plus 1, 2, y2 plus y1 by 1 plus 1, 2. So the formula for midpoint is x1 plus x2 by 2 and y1 plus y2 by 2. There's again a very important formula to remember. Then points of trisection. The points of trisection of the join of a x1 comma y1 x1 comma y1 and b x2 comma y2 are, okay, m1 is x2 plus 2 x1 by 3, then y2 plus 2 y1 by 3. Yeah. Then and 2x2 plus x1 by 3 and 2y2 plus y1 by 3. Okay. Now, how am I writing these formulas? It is neither I am looking into the book nor I am memorized it. Just by logic, I am writing. Okay. How am I writing this? See, what are points of trisection? Now, points of trisection
It divides the line in 3 parts.
are points which divide AB, the line segment, in the ratio 1:2 and 2:1. So this is the point A, x1 comma y1. This is the point B, x2 comma y2. And we have points M1 and M2. So AM1 is to M1B is 1:2. That means this length is, if this length is 1, this length will be 2. If this length is L, M1B will be 2L. Okay. And AM2 is to M2B is 2:1. That means these are 2 parts. If the line is divided into 3 equal parts, AM2 forms 2 parts and M2B forms 1 part. AM1 forms 1 part and M1B forms two parts. So 2:1. So these are internal divisions. This is internally. So these internal divisions, how do we do these internal calculation now? So I take M and N as 1 and 2, and I apply in this formula. M equal to 1, N equal to 2. Then I get x2 plus 2x1 by 1 plus 2, 3. So that's how I get this result. M is 1, N is 2. So I get 1 times x2 plus 2 times x1 upon 1 plus 2, 3. Then I get 1 times y2 plus 2 times y1 is equal to 1 plus 2, 3. Whereas for the second case, it is 2:1. The first case is 1:2. The second case is 2:1. So M is 2 and N is 1. So 2x2 plus 1x1 by 3, 2 plus 1, and 2y2 plus 1y1 by 3, 2 plus 1. So 3. So that's how we write these divisions. And all these formulas, mind you, are extremely important, and we should learn these formulas. Very important. We should commit to memory by practice. Okay, these are basics which we must have done, but I'll give you one problem. I want you all to solve. You both to solve this. Find the midpoint and the points of trisection find the midpoint and the points of trisection of the line joining A 1, 2 and B 6, 12. Okay, I'll give you time to solve. Please solve and tell me. I'll check in how much time are you solving. Good. One answer.
Completed.
Pardon?
Midpoint 7/2, comma 7.
Yes, that is correct. First one. How about the second?
Point of trisection with respect in the ratio 1:2,
Hmm.
8/3, comma 16/3.
Okay, very good.
In the ratio 2:1, 13/3, comma 26/3.
Okay, let me see the second one. I just want to check. Okay, good. Within 3 minutes, you did it. So, midpoint M is x1 plus x2, 1 plus 6/2, 2 plus 12/2. So it is 7/2, comma 14/2, which is 7. Now let M1 and M2 be the points of trisection that divide AB in the ratio 1:2 and 2:1 respectively. Okay. So M1 will be, so I usually write like this. So as to never make a mistake, I will write the points. Before you can do mental calculations, you should be able to do this. So M1 is 1:2. So I get 1 times x2, that is 1 into 6 plus 2 into 1 by 1 plus 2. Then 1 into 12 plus 2 into 2 by 1 plus 2. This is 6 plus 2, 8/3, comma 12 plus 4, 16/3. M2. Of course, here in this formula, replace 1/2 and 2/1. But better is to do this without making a mistake. This is 2:1. So 2 times 6 plus 1 times 1 by 2 plus 1. Then 2 times 12 plus 1 times 2 by 2 plus 1. So this is 2 times 6 is 12 plus 1, 13/3. And this is 12 to 24 plus 2, 26/3. Okay. So right, your answers were right. So this is the points of trisection, M1 and M2. Okay. So this was about midpoint and point of trisection from the section formula. Now we have to do something with the areas. area of a triangle. If A x1 comma y1, B x2 comma y2, and C x3 comma y3 form three vertices of a triangle, then the area of the triangle is A. This A is the area, not the point A. This is the area A, or sometimes written as delta. A or delta is equal to half modulus of x1 into y2 minus y3 plus x1 times y2 minus y3 plus, replace this x1 by x2, y2 by the next number in cycle y3. Now y1, y2, y3, again y1 in cycle, x1, x2, x3, y1, y2, y3. After y3 again comes y1. So y3 minus y1 plus x3 times y1 minus y2. See, the sequence is very, very important. Very, very important sequence. Sometimes this is written as sigma, modulus of sigma x1, y2, y3. When we write the sigma x1, y2, y3, it means it is a cyclic. After x1, you should write x2. After x2, you should write x3. So in the next term, you will get x2 plus x2 times. Now replace y2 by y3, y3 by y1. Next term will be after x2 comes x3. So then this one will be y1 minus y2, because next sequence of the numbers. This is the area of the triangle. Now there is another beautiful method to find area, and I recommend this to all students. You will never make a mistake. Write half modulus of, let this be within modulus. Start with the vertices. You write like this: x1, y1, x2, y2, x3, y3. After that, in cycle, see, it is like this: A, B, C. To form this triangle, you go from A to B, then from B to C, and again from C, you come back to A. So similar concept, A, all right, from A to B, B to C, from C to A, right, again. So write the coordinates of A again. So I write modulus of x1, y1, x2, y2, x3, y3, x1, y1. This is not any operation. This is not a standard thing. Now what we do, we should multiply y1 by y2, x1 by y2. The left up to down right should have positive sign, and down left down to right up will have negative sign. This one will have positive sign, this one will have negative sign. Positive sign, negative sign. Now let us write the product and see. This is half times modulus of x1 y2 minus x2 y1 x2, right? Plus this one will be plus x2 y3 minus x3 y2 plus x3 y1 minus x1 y3. So this is the equation, or this is the expression. Delta is equal to this. Now let us collect terms of x1 and c. If you collect, this is x1 here and x1 here. Collect x1, take x1 common, you will get y2 minus y3. Then take x2 common, you have y3 plus y3 and minus y1. So y3 minus y1. And then take x3, you get y1 minus y2. So this is same as what we got here. x1 times y2 minus y3, x1 times y2 minus y3, plus x2 times y3 minus y1, x2 times y3 minus y1, plus x3 times y1 minus y2. Here you get the same x3 times y1 minus y2. So we see we get the same result, but this way of doing we'll never fail to get the correct value. Here, remembering the sequence may be a little difficult, but in this case, we will never make a mistake. This is the area of the triangle. We calculate like this. Now, area of a polygon. This is area of a triangle. Area of a polygon. Formed by n vertices. If a1 x1 comma y1, a2 x2 comma y2, and an xn comma yn are n vertices of a polygon, then the area of the polygon is delta is equal to, again, half, we write x1 times y2 minus y3 plus x2 times y3 minus y4 in sequence. All right, so on. And the last term will be xn times y1 minus y2. Like this in cyclic, or we will write this in the similar manner as summation of x1 times y2 minus y3. This denotes that. Best way, again, as I say, you write all the coordinates of all the points in a sequence: x1 y1, x2 y2, x3 y3, so on, xn yn, x1 y1. So after all points are completed, you must again write the first point. Okay, and then this is not a determinant sign, this is just a modulus sign. And this is just to help us do the calculations. Here dot 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 indicates that there is a sequence of numbers that come in there. So this is half modulus of, you see, x1 y2 minus x2 y1 plus x2 y3 minus x3 y2 plus so on. The last term will be xn y1 minus x1 yn. Okay, this will give us the area of the polygon. Without fail, you will get the same value. You can cross check it and see that you will get the same value. It may not immediately match this one, but you will get the same value if you follow this sequence. All right. This yeah, I made a small error here. This is not the sequence like this. You have to skip one. This will have a difference of 2. So x1, y2. Okay. It will have y2 minus yn. There will be this gap. For triangle, it was y2 minus y3. In the sequence, whichever is the last, 1, 2, 3. 1, 2, 3, right? The first multiplied by second minus the last. So x1 into y2 minus y3 was in the case of triangle. In the case of a quadrilateral, it will be x1 into y2 minus y4. In the case of pentagon, it will be x1 into y2 minus y5. In the case of a polygon of n sides, it will be x1 into y2 minus yn. The next term will be, okay, next increase by 1, y3, x2 into y3 minus next of yn, the next one is y1. Similarly, when you go to n, after that, you will have y1 minus y1 minus, again with the gap, it will be yn minus 1. So like this, we can do it and we'll get this result. We'll get the same result. Best is to remember this one. You will never make a mistake. This will give you accurate result always. Okay, so this is about the area of the triangle and area of a polygon. So quadrilateral, pentagon, hexagon, octagon, everything, you can find the areas like this. This is coordinate geometry. We are not doing any geometrical calculations. Just by geometry, we'll get this. Now, some important things, important points in a triangle. important points in a triangle. Now, first of all, concurrency, point of concurrency definition. Okay. Now, if three or more lines, if three or more lines pass through a common point, then the lines are said to be concurrent, and the common point is said to be the point of concurrency. So the lines are said to be concurrent, and the point is called as point of concurrency. So if two or more lines, so we have 1, 2, 3, 4, these are concurrent lines, and this is the point of concurrency. Okay, this is the point of concurrency. Now, in a triangle, there are many concurrent points. Okay. The very first one, the important points in a triangle, the very first one is the centroid. Very, very important point. Now, a median, this is centroid. Now, first of all, we have to define a median. In a triangle, a median is a line joining one vertex of a triangle to the midpoint of the opposite side. A median is a line joining any one vertex to the midpoint of the opposite side. Now, so there are three medians in a triangle. All right. The medians, the three medians of a triangle are concurrent. They are concurrent, and the point of concurrency is called as the centroid. denoted generally by G. The point of concurrency is called as the centroid. The medians of a triangle are concurrent. Okay, so let's take any triangle. Let's say this is A, this is B, this is C. Midpoint of BC is D, midpoint of CA is E, and midpoint of AB is F. It will not be perfect. I'm drawing freely without calculation, so it may not be perfect, but let's draw this. So from A to D, we join A to the midpoint of the opposite side. So this is one median. From B to E, we draw another line. And from C to F, we draw another line. So this common point of intersection is G, the centroid. Now the coordinates of the centroid are, see, let's say A is x1 comma y1, B is x2 comma y2, C is x3 comma y3. So coordinates of the centroid are G is x1 plus x2 plus x3 upon 3 plus y1 plus y2 plus y3 upon 3. How do you get this? Because very important note, the centroid divides the median in the ratio 2:1. So first, this is midpoint. We can find very simple. This proof is very simple. This is midpoint. D is the midpoint of BC. So you will get this as x2 plus x3 by 2 by 2. Then y2 plus y3 by 2. And then AG is to GD is 2:1. So 2 times this coordinate plus 1 times this coordinate. So 2 times this coordinate will give us x2 plus x3, 1 times x1. So x2 plus x3 plus x1, that is x1 plus x2 plus x3, divided by 2:1, 3. So x1 plus x2 plus x3 by 3. Similarly, we'll get y1 plus y2 plus y3 by 3. Okay, so centroid divides the median in the ratio 2:1. So we talked about medians. Then in the next class, we will discuss angular bisectors. We'll discuss in-center. We'll discuss x-centers. We'll discuss orthocenter and circumcenter. These are the points in the triangle, critical points. In the next class, we'll continue.